Okay, continue on with questions 3 and 4. These are questions based on gears. The main formula you need to remember with this type of question is that mechanical advantage, I'll just get the pen working, MA, mechanical advantage for gears, simple gears is equal to driven gear, that's the one being pushed by the motor, sorry, the one that's being pushed by the one that's being pushed by the motor, so the second gear, driven gear over the drive gear, and the drive gear is the one that's attached to the motor. Okay, so this one here, the drive gear, is the one that's got the motor attached to it. Okay, you've got to remember that. Okay, so for this question, it's really simple. They say here for a gear system where A is the drive gear, so A is the one that's being driven by the motor. We put the they're going to put that one on the bottom, and this is the driven gear B. So we say MA is equal to the driven, and we can use circumferences, we can use radiuses. In this case, we've got teeth. They are all the same size, so they equate to a distance. So we can say it's equal to 30 over 10. Cancel down our 0, it's equal to 3. Now, if you're going to express that as a gear ratio, you could say this would be 1 is to 3, or if it was going the other way, 3 is to 1. But you really don't need to worry about that. But if you ever were asked for gear ratio, that's how you would do it. You just expressed it as an expression of to 1. So this is the mechanical advantage, 3. Okay, which gear spins faster? Now, some people had a bit of trouble with this, but when you think about it, every time this gear, the drive gear, goes around once, okay, it's gonna pass through 10 teeth, which is exactly 1/3 of the distance around this wheel. So every time this spins once, this wheel has only done 1/3 of a turn. So it takes this will spin around 3 times before this has spun around once. So this is spinning 3 times faster. So you would say A spins faster. Now, if you had the situation reversed and B was the drive gear, we didn't ask you about this, but if you did have B as the drive gear, then every time B spins around once, okay, this would spin 3 times. So B would be spinning slower. Okay, so it's kind of counterintuitive, but you've just got to remember, you just got to think about how far one is going in relation to the other. Okay. Think about it. Watch a few of the gear videos on Exchange if you're a bit still confused about it. Come and see me if you want a bit more of an explanation. What is the mechanical advantage if B is the drive gear? So B is suddenly the drive gear, so that goes on the bottom. So it's just equal to MA. You just flip the fraction over. You say 10 over 30. So it equals 1/3. So because it's less than 1, it's not a mechanical advantage at all to have B as the drive gear. But what will happen is it's a speed converter. So rather than being a torque converter where A spins fast and B spins slowly, in this case B is the drive gear and A spins fast. Okay, so it's a way of increasing speed rather than torque. Okay, so and torque being the power of the system that you can, the amount of force that needs to be applied to get a given amount of work done. Anyway, all you need to remember is that if it's less than 1, you're going to have speed increasing rather than torque increasing. Just remember, mechanical advantage is driven gear over drive gear, and that'll get you out of a lot of trouble. We did these compound gear problems. All you need to do is think about them as 2 simple gear problems for a system with 4 gears, and then multiply the results. So you're starting at the left, which is the A, and you're getting through to D. If this was a simple system where one goes through to the next, goes through to the next, and they weren't compound, you'd just basically have to work out this one and say driven over drive, and you'd get the result. Okay, but for a compound gear system, a little bit more complex than that, because you've got one gear that's sandwiched on top of the other. So for this type of question, and we did an example in class, you need to say driven over drive for AB. So first we're going to work out the mechanical advantage of AB. And once you've worked out the mechanical advantage for, I'm going to just write that a little bit more neater than that because I've made that impossible to read. Mechanical advantage of AB B, okay, is equal to driven over drive. So B is 32, so we say 32 over 16. And that will give us an advantage of 2. And then we work out the mechanical advantage of C and D. C, D. And that's going to be equal to 42 over this gear here, which you can't see, but it's 14 teeth. So we end up with 42, which is this D gear, over the C gear, which is 14. 42 over 14. And that gives us a value of 3. And then to work out the total mechanical advantage, and I'm just going to put that just over here, the mechanical advantage total is going to be equal to, put it here, the mechanical advantage of AB times the mechanical advantage of CD. Now I had a few people add those two figures together. So we just say 2 times 3. 2 times 3, that equals 6. And that's how you do a compound gear problem. Just break it down into two simple gear problems. Okay, last thing I'm going to talk about on this page before we do the final 3 questions is we're going to just talk about ways of reversing the rotation, which was question 5. Okay, so question 5 said, how do we reverse the rotation of a shaft? Well, one way is you can just have a simple pair of gears, okay, like we had up here. That is a simple pair of gears. So if A is spinning in this direction, you can see that B spins in the opposite direction. So a simple pair of gears will change the direction. So a simple pair of gears was one answer. Some people said an idler gear, but just remember an idler gear is actually put between these two, okay? It doesn't matter what size it is, because remember how with a simple gear system we're only interested in the output and the input. But what the idler gear does is it makes the flow go in the same direction as the drive gear. So it's a way of keeping the rotation the same, okay? So a simple pair of gears reverses the rotation, and the other way is you can have a band and pulley system with a band drive on it. And what happens is you, instead of having, if you've got a normal chain and sprocket or band and pulley system like this, if the band's going this way and this pulley's spinning in this direction, then this will spin in the same direction. So that's not going to change our rotation direction at all. It's a way of keeping it the same. But if you actually twist this belt, okay, over a vast distance so it doesn't touch itself, you can reverse the direction of rotation. So you can call it a twisted band and pulley system plus pulley system. And that's the two ways of reversing rotation. I'll try and get a video showing that twisted band. It was used in the Industrial Revolution quite often for driving steam type machinery. And that's those 3 questions, and I will upload those solutions. And if you have any questions regarding those solutions, please do not hesitate to contact me.